Welcome back. This is section 5.2, and we're going to do more stuff with exponents. In this section, we're going to use the power rule for exponents, and we're just going to use exponent rules to simplify a whole bunch of different kinds of expressions. So first, I want to help motivate you to understand the power rule. I'm looking at 2 cubed to the 4th. I'm going to simplify this using the order of operations, which says first you do the stuff in parentheses. So I have 2 cubed to the 4th power. Inside the parentheses, 2 cubed is 8. And 8 to the 4th power is 4096. Okay, now grab your calculator, do a little bit of trial and error, and see if you can figure out what power of 2 equals 4096. I'm going to give you a second to think about that while I write down a couple of my own guess and check trials. So the two things that I would think of trying are 2 to the 7th, where I added the 3 and the 4, but that only comes to 128, which is definitely not the right answer. It's pretty far away. So instead I'm going to try multiplying the 3 and the 4 and get 2 to the 12th, which is, the same thing. So it looks like if I have a power to a power, I can multiply those two, maybe, to get the new power. Now that we've got a little bit of intuition, let's back that up a little more. 2 cubed to the 4th means take 2 cubed and multiply it by itself 4 times. So that's 2 cubed times 2 cubed times 2 cubed times 2 cubed. Now, each of those 2 cubes means to multiply 2 by itself 3 times. If I expand that, how many 2's am I multiplying together altogether? Well, there's four groups of 3 2's, which is a total of 12 2's, or 2 to the 12th power. Now, this is kind of a long way to go about figuring that out every time you want to. What you can do is remember the power rule. If you have something to a power, you multiply the powers. In my own words, I might say when a number or a variable is raised to a power and then that whole thing is raised to a power again, you can multiply the powers and leave the base the same. When you see this power to a power, I do recommend that you think about it the way that we did up here. 2 cubed to the 4th is 4 groups of 3 2's, which is the same as 12 2's. We've got 2 more rules to go in this section, but these last 2 I think are pretty straightforward. We're going to explore this first potential rule by looking at what happens when I have 2 things being raised to a power at the same time. Now, 2x cubed means to take 2x times 2x times 2x. Now notice, since this is all multiplication, it doesn't matter what order we do it in. So this is 2 times 2 times 2, which is 2 cubed, and x times x times x, which is x cubed. So what that means is that when I had 2x cubed, I could have just cubed the 2 and then cubed the x. Speaking of which, I should probably finish simplifying this since I know what 2 cubed is. 2 cubed is 8, and x cubed just stays as x cubed. So the power of a product rule just means that if you have 2 things inside being raised to a power, you can raise each thing to the power individually. In my own words, I might say, if 2 things are multiplied and being raised to a power, you can raise each one to the power individually. It is important that you notice that these 2 things are being multiplied, and that's what makes it possible to raise each one to the power individually. Later on in this course, we're going to look at when 2 things are being added in here, and that's a whole different story. But don't worry, we won't try to trick you with that for a while yet. Finally, we're going to get to our last rule. Consider x over 4 cubed. That means x over 4 multiplied by itself 3 times. So that's x over 4 times x over 4 times x over 4. Remember that in fraction multiplication, we multiply straight across. So in the numerator, I'll have x times x times x, which is x cubed. and 4 times 4 times 4, which is 4 cubed. So essentially, I was able to cube the x and cube the 4 separately. It's an awful lot like that last rule. And finally, I really should probably simplify this since I know what 4 cubed is and rewrite this as x cubed over 64. So this is the power of a quotient rule. It's an awful lot like the power of a product rule. If you have something being divided and then the whole thing being taken to a power, you can just take the top to the power and the bottom to the power separately. So in my words, I might say if a fraction is being raised to a power, you can raise the top to the power and the bottom to that power separately. Okay, that's been a lot of exponent rules. Let's do a quick review of all those exponent rules that we just learned. There's the product rule, where you multiply two things, and then you can add their exponents if they have the same base. So x cubed times x to the 8th will be x to the 11th. And y to the 6th times y to the negative 4 is y squared, since 6 plus negative 4 is positive 2. There were negative exponents, where a term that had a negative exponent could be flipped to the other side of the fraction to make the exponent positive. Negative 3x to the negative 5th will become negative 3 over x to the 5th. Notice that only the exponent changes there. The negative 3 can just stay the way it is. Here I have 7 over x to the negative 2. I'm going to flip that x to the negative 2 to the top of the fraction and make that 7 times x squared. Notice that a 1 is left behind, but you don't really need to write that since anything divided by 1 is just itself. There was the quotient rule, where we saw that if you had two things being divided, you could subtract the exponents, so that x to the 5th over x squared became a single x cubed. Y cubed over y to the 7th will become y to the negative 4th, and we usually fix that by rewriting it as 1 over y to the 4th. And finally, there was this zero exponent rule, where anything raised to the 0 power is just 1. Today we added 3 more rules. The power rule, where something raised to a power and then raised to a power again, means that you'll multiply the two powers. Remember that this is x to the 5th multiplied by itself 3 times. That's 3 groups of 5 x's, or 15 x's total. Here I've done a little bit of combining. I have negative 3 times x cubed being squared. Negative 3 squared is positive 9, and x cubed squared is x to the 6th. Over here we have the power of a product rule, where we said that if you have two things inside being raised to a power, you can raise each of them to the power individually, so that this becomes 4 cubed times x cubed. And then if you have a number that you can simplify, you should. We know that 4 cubed is actually 64, so this is 64 x cubed. And finally, there was the power of a quotient rule, where we were able to say if you have stuff that's being divided, you can raise the top and the bottom to the power individually, so that this becomes negative 2 cubed over x times y cubed. And then we should continue simplifying as much as we can. Negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. And x times y cubed, remember the product rule, power of a product, is x cubed y cubed. That's a lot of rules, and using them all together can be a little bit tricky at first. The best thing you can do to master these rules of exponents is practice, practice, practice. You'll notice you have lots of practice in your homework, and there's even more practice available if you want it. It's also valuable to remember that there is often more than one way to do a problem. As long as you're using the rules correctly and doing things that are mathematically appropriate, you won't go wrong. but you may do a problem somewhat differently than your friend does, or your neighbor, or the solutions manual. And that's okay, as long as you're all ending up with the same expression in the end. So I just told you that practice is really important. So I've got 4 problems here for you to try before you start on your homework. So go ahead and pause the video here, try these problems, and then I'll show you how I did them. Okay, have you given those problems a shot? Here's my work. I'm going to talk through each of these problems the way that I did it. Now, x to the 7th to the negative 9th, I'm going to multiply those powers, since it's a power to a power, which gives me x to the negative 63. We don't usually consider an exponential expression simplified until all of the exponents are positive, so I'll use that negative exponents rule to rewrite this as 1 over x to the 63rd. This one is negative 8x cubed squared. I'm going to square both of the pieces in here. Negative 8 squared, x cubed squared. Negative 8 squared is 64, and x cubed squared is x to the 6th. This problem is a good example of a place where you might be able to skip some steps. So I wrote down the negative 8 squared and the x cubed squared part, showing you that we're using the power of a product rule. It's entirely possible that you will feel comfortable going straight from negative 8x cubed squared to 64x to the 6th, and that's okay. This third problem has a whole bunch of stuff being raised to the 3rd power. Everything inside is multiplication and division, so we can use the power of a product and power of a quotient rules to say that I really just need to cube all 3 of these pieces, which is what I wrote down here. Then 3 cubed is 27. A to the negative 4th to the 3rd power is a to the negative 12th. I have a power to a power, so I multiply the powers. And similarly, b to the 7th cubed is b to the 21, 7 times 3. Now I'm so close to being done, but that a to the negative 12 is bothering me because of the negative exponent, so I'm going to move it from the top of the fraction to the bottom of the fraction, giving me 27 on top, and a to the 12th, b to the 21st on the bottom. Finally, let's look at this third problem, which really does look a bit strange. I have 2, and then y cubed to the negative 3 over y to the negative 3. I decided to start by dealing with the y cubed to the negative 3 and making that y to the negative 9. Then I decided to fix all of the exponents by moving the y cubed upstairs and the y to the negative 9th downstairs, giving me 2y cubed y to the 9th. Now this is a moment when there's at least 2 ways that you can think about this. I've showed you to think about the y cubed over y to the 9th as y to the negative 6th. I subtracted exponents. I did 3 minus 9 to get negative 6. However, it's also perfectly fine for you to think about this in terms of canceling. There are 3 y's on top and 9 y's on the bottom. When I cancel, I'll be left with 6 y's on the bottom. Do you see that either way we end up with 2 over y to the 6th? Don't worry if you don't feel like you've completely mastered exponents yet. That's okay. It takes a lot of practice to master this. Practice that you're going to get when you're working on your homework. It's perfectly normal to feel like you don't quite have it all down yet. Just keep practicing and keep asking questions, and you'll figure it out soon.